Perfect. So welcome everyone. Super great to be here. So myself, originally born and raised in Prague, always great to come back, and especially this is a very special building to the people from Czech Republic. So it's a great honor to be here and present. As a part of my current activities as space computer, I'm one of the CTO and co-founder. So definitely happy to try to make you space build to see what we are building and where we see the future of space. And with my other hat, I'm also a PhD candidate at the Technical University of Munich. So definitely great to see also a few familiar faces from the TUM who came all the way here from Munich to do some cool hacking over the weekend. So as a part of today's talk, I'm covering our future architecture for space computer, which we call Space Fabric. And overall, I will try to guide you through some of the challenges that we see with space and where we see a lot of potential on how actually can we try to play a role, hopefully not too small a role eventually, in how the future space interaction itself can look like. So without further ado, let's dive into the details. Maybe at the beginning, a quick raise of hands. Have you heard about space data centers? Okay, so there are some people who are definitely a little bit familiar with that topic, which is maybe good on the marketing sides. SpaceX and other companies are doing a very good job. I won't be asking what do you think about space data centers, because that will be definitely taking a long time, and I think there is still a lot of debates on if it makes sense or not. But the general trend is that there will be more compute shifting to space, which is definitely very important for us. And what we definitely see that space is open for business more than ever before. And we definitely see that already, if you look for the past decades, a lot of stuff were happening and moving to space, either for communication, but the computation was still a little bit lacking. And we see now that actually massive compute capabilities will be unlocked in space. But if you look at the infrastructure under the hood, it's not there yet. So before diving into that, I just want to also a little bit motivate what is the unlocking capabilities of why is more compute shifting to space. And mainly it's due to the fact that SpaceX is doing a very cool job with respect to building rockets that can not only fly up and explode or whatever, but actually can also come back, be refurbished, and be again flying rather soon. So this is happening pretty much almost every second day. A rocket is flying up, sending more payloads, and with the next set of rockets, especially the Starship, we will see even higher increase of volume of payloads being shipped to space. So of course, this is definitely an unlocking capability that can later on make capabilities of compute in space by being in general able to shift much bigger bodies of satellites into space either at once, but also especially for a fractional cost in comparison to what we know as of now. And as of now, actually, if you start to look more under the hood, some of the aspects that will definitely be affecting, maybe already are affecting your lives day to day, depending on where you are based. Maybe you're already using Starlink or other technologies. We see that security should be part of it more than ever before, because we see that satellite-based communication is being used for critical infrastructure. And we see that there's a huge market with respect to computation and requirements to grow steadily. So already as of now, we are already in the tens of billions of dollars of valuation as the current market, and it's going to be only growing because we see that people are seeking for edge compute capabilities in space. People are also looking for the ways on actually how to run sensitive software, algorithms, be able to store keys. That can, of course, vary depending on the use case itself. And last but not least, since you will have general purpose compute in space, you can think of also applications that are space native. And this will definitely be unlocking your imagination in the first place. So you can go nuts, like really think, what do I do if I have the option to explore ideas and do the computation in space? But definitely you can also think about how does the model between Earth and space with respect to designing your solutions actually look like. So if you look at the state of space, we are definitely not there yet, right, with respect to that. We definitely see that the headlines are massive. We see Starlink launching hundreds of satellites, always more capable. But if you look actually under the hood, many of the aspects of the other infrastructure are definitely very static. Like there was a recent study actually showing that around 50% of satellite traffic is currently not even encrypted. So if you look at like the Ethernet analogy to what we know from Earth, everyone is pretty much using HTTPS solutions as of now. But with respect to space, we definitely need to do much better with respect to providing solutions that users are used to from interacting with your solutions on Earth as well. So overall, we try to approach it by the fact that we try to crawl before we walk. and walk before we run to really set up the robust foundations. And this is something that we have been working on together with the team who is here and now finally manage, after roughly a year of building, give you as hackers the opportunity to play with some of our technology and in general try to unlock and showcase that actually space is really open, and we would like to bring the usability we are used to on Earth, but basically see that the capabilities it can provide are limitless. So how does the space journey actually look like? From a satellite to a constellation, how are the things working up under the hood, right? So you can think of it, you have the users on Earth that are hopefully some of you when you are hacking on our challenge, but of course in the future it will be more of you, interacting with the ground stations that are responsible for forwarding the traffic to the constellation in space. And later on, we can do compute, but we can also, of course, be also fetching information and data from space. So this is the general flow, and of course, we would like to make this channel between the user and the satellite infrastructure as much as seamless as possible. Providing also a bit of a context how actually compute payload in space looks like. We, in general, can think of it like we have a massive aluminum box, where the reasoning for aluminum box is simple. Even though space is a huge vacuum of space, and it is very cold, the main challenge with space is the heat dissemination. So even though if I'm running my compute, the heat from the chips actually itself doesn't really easily disseminate. So I have to find a way on how to use good conductors that can actually disseminate the heat. So if you look at the ratio with respect to the power and the amount of cooling you need, it actually ends up being quite a bigger chunk of the payload is actually consumed by the cooling capacity you need to cool down your hardware itself. And because of that, you're actually looking into the ways on how to have rather integrated smaller PCBs or the printed circuit boards that are following certain type of standards. And you are dividing the compute between two types of general onboard computers. One is the mission computer. So this is something that is actually responsible for maintaining and orchestrating the satellite itself. And then you have the onboard computer itself, which is making sure that everything is actually operational. And of course, you want to make sure that you are able to connect certain telemetry and make sure that all of the heat and the management of it is properly dispensed. And then you have the communication modem that is responsible for the communication with your particular satellite as well. So here are some photos. On the left is an example how this, basically, with respect to the scale, how the heat passive cooler basically look like. And later we can also see all of these copper wires that are basically later maybe even attached to the satellite itself to make sure that the heat can properly disseminate and be reflected to the space. And on the right, actually, you can see our payloads that are currently developed and will be shipped to space later on this year. As of now, they are missing the cooling, which is something we are still working on, but we still have a couple of months, to finish stuff. But definitely happy to share soon the pictures with you as well on actually how our compute payload gonna look like in the future. So now when we covered the compute itself, let's actually try to unfold what are some of the unique features what we can use the compute for. And this is the last part of the talk, which will be becoming a bit more technical, but we'll be definitely also happy to take your questions afterwards if you are interested in more details, which is actually how do we shift from orbital compute to space fabric, and how can we actually rethink the security beyond Earth as well. So if you look at the current state of orbital infrastructure, it is not really scalable by design. You usually have a purpose-built silos, where every satellite that is being designed and launched and licensed is usually for a particular customer. What does it mean in practice? Usually one satellite equals to one user, which of course by design, as you can think, doesn't really scale. If you look at the scarcity at scale as well, it's basically, even though SpaceX is doing a great job, even if you want to go and now book that I want to build a constellation of 30, 40 satellites, you will have to wait a bit because the demand is way higher than the possible supply of the amount of rockets being shipped. So you actually have to fight for even getting a spot on a rocket. And this basically leads into a congestion when you actually want to and can deploy the capabilities to space. So the last part that we gonna see as well is there is lack of coordination. So basically, everyone is running their compute for their particular mission, and there is not like a clear orchestration with respect to how can we utilize the resources of the operation in space way better. And this, of course, is something that, as you can see, is leading to not very efficient system. And this is basically where we see a great opportunity as a part of Space Computer to make sure we can utilize all of these resources in a way better fashion, and we can provide trust minimize capabilities with respect to the multi-tenant solution enabled by the compute fabric. We can also try to look into having same or similar orbital hardware across different parties. And we definitely want to solve the main challenge, right, which is the sensitivity. The reasoning why currently one software equals one user is because the fact that there is quite a lot of complexity, and especially I think the software that is maybe operating on the devices itself, you don't maybe want to have a visibility and showcase it to other users themselves. And this is basically where the technology that we are using comes into picture to unlock the opportunities of the future. With space comes a lot of challenges, which I'll be talking on the next slide, but there is also a lot of great opportunities. It's physical and inaccessible, which can serve as a great way on how to provide additional security. Depending from where you launch your satellite, you can actually operate in a very jurisdiction-friendly environment. And the good part, especially as we can see with current geopolitics, sometimes it's a good way to have an option to bypass terrestrial exposures to different type of capabilities as well. And we definitely see that if we are managing to optimize for the utilization, we can lower the cost and barrier to entry for everyone. So basically, instead of like being a startup or even like a large-scale enterprise that needs massive amount of funding to be shipping the stuff to space and you having your own infrastructure, you can actually find a way on how you can reuse already existing compute in space, which will of course enter the barrier to entry. The great part about space, it's actually scales. If you have a constellation of 30 satellites or 60 satellites or 150 satellites or even thousands of satellites, the properties of the overall network will be also getting better. Because if you have more satellites in general, it also means you will have more satellites flying over your particular area. You will have better connectivity with more ground stations. And also the overall bandwidth the system can handle is way better as well, which of course can again leads to unlocking new use cases where you are happy with maybe paying slightly bit more for better offering and guarantees as well, which is the last part, which is the additional security we can be getting from space environments themselves. So kind of diving a bit more into the detail, actually, how would this interaction look like? I hope you can actually see it, because the light here is not the greatest, but I will try to walk you through it. So we have here the users that are basically already having the accounts as they are used to. They can interact with it. Then we have our gateway we call Orbit port, which is meant to be to interact with the space infrastructure. And in between the chunks is something we want to really make abstracted for the users themselves. You can think of it that the space infrastructure is very heterogeneous. You have people that are already using APIs that we are used to, but you actually also have some providers that are currently relying on mailboxes to be sending your commands to space. Then behind it, you have the communication layer, which is the physical bound itself, which are the ground station providers that are only sending over the bits and bytes to your particular infrastructure. And then, of course, as you can imagine on top, you will have different type of satellite providers, which can be you, can be us, but it can be also any type of third-party infrastructure itself. And we would like to kind of find a way on how we can make this more unified and streamlined, and also secure all the way end-to-end. So the talk is especially focusing on what we can see on top, which is the part of the space fabric satellites. Maybe also a quick raise of hands. Who has heard about trusted execution environments before? Great, it's a big T crowd. Who has heard about some hacks that were happening on trusted execution environments before? Not so many, not so many. So actually you heard the good stuff about TEs. And I'll be talking also about the stuff about that are a little bit bad, but basically it's something that we can try to rethink and provide a bit of a better solution as well. So just for completeness, want to also a little bit define what are TEs. You can think of it like a small isolated region in a CPU that is providing you as the user that is developing the software on top of it, additional set of instructions, which if you are able to unlock them properly, you can actually have a way and small vault enclave where you can actually later on run and operate your code and data in a very sensitive fashion. And the cool, crucial part, if you look at it from the previous activities that we are aware of, you have data at rest that can be already protected with current technologies. So you have, for example, your disk can be encrypted. It's perfect. It's already working for a long time. You have data in transit, you have an encryption, you have TLS and other protocols, but data in use is something that is a little bit tricky. And for that, TEs are like really playing a crucial role. And it's not something that actually we are inventing, it's already being used for quite some time. We are just trying to take this technology and build it for the infrastructure of the future itself. And of course, we want to remain the capabilities, which is to provide confidentiality and integrity of the computation happening inside of this secure environment. And not only that, because if we do it for ourselves, it's great, but we also want to have a way on how can we convince others and the users of the system that the computation was happening in this type of enclave. And for that, we are relying on the remote attestation capabilities that are provided by the system itself. So providing a bit of a context on what type of trusted execution environments we generally have, we are differentiating between both process-based solution, such as Intel SGX or ARM Trust Zone, which you can think of that you are running your application and only in a particular capability of the compute will be actually happening inside of the TE. And then on the other side, you have a virtual machine-based solution. As you can hear kind of from the name, you're basically putting the whole virtual machine itself into this secure vault. And for that, we have two major manufacturers currently building this technology, such as Intel TDX and AMD CVSMP. We also see a solution from ARM that is not in the market yet, but hopefully will be getting there soon. But what we see as one of the bottlenecks for this technology is that they actually can be physically tampered with. So in case you are having a manufacturer, not only a manufacturer, if you are having a provider who is offering you the solution, theoretically they can go and try to compromise the TEs themselves. So the general threat model currently assumes that you have the guy with the Glock that is basically standing at the door and is making sure that no one can really do something about it. Which especially in the Web3 space itself, if you see some of the recent attacks on TEs, is not taken very well because people are quite unhappy about this type of challenges, especially if you want to build decentralized applications themselves. This is the part where kind of we want to offer the solution, which is, of course, trying to solve some of the challenges, but not only that, but try to push the frontier with respect to some of the technological aspects that is unique to space as well. So for those that have visited our booth, we have also a nice T-shirt for you that you can take a little cheat sheet with you, having the Space Fabric paper printed on it. Not in the full length, of course, but at least the initial information there. So definitely stop by later on if you want to get a copy. And I will try to unlock some of the features that are, from my point of view, novel with respect to what we are actually covering in the paper itself. And kind of starting first, let's try to position the solution itself. And we kind of want to focus on two unique features, which is we want to provide a hardware root of trust in addition to the physical isolation provided by operating stuff in space as well. We do it in layers, and the reasoning for that is because currently we see with taking, for example, already existing solution to space, for example, taking Intel TDX or AMD CVSMP, just sending it to space will, of course, help you with some of the challenges that we are aware of from trusted execution environments as they are, but it doesn't necessarily tell you and solve all of the issues, where especially the important one for us is the hardware root of trust, that, for example, in the case of Intel technology, still lies with Intel or other party. And the other challenge we see with TEs, they tell you what code is operating, but it doesn't tell you where it's actually operating. We still kind of see the challenges with auditability and supply chain, because of course, even if I want to send TE from Earth, it's possible that during the supply chain, before the things were shipped, something could have gone wrong, right? The supply chain is very complex and requires a different type of approach to it. And last but not least, we have especially seen in the recent weeks, months, a lot of discussion regarding post-quantum cryptography, and we definitely have to have this solution in mind, especially for solutions that will be running in the next years and hopefully will be operating for the next decades. So this is something that we try to cover as a part of the overall story itself. And in short, how we plan to address it is that we want to make sure that the keys that are being used as a part of the attestation are never, ever generated on Earth. This is, like I would say, a very crucial part. And for that, we are relying on two dedicated secure elements, where depending on who is the user and the customer, of course, they have different appetite for risk. But in general, we see that advantage of having two solutions can provide you a mixture of both. One of the solutions we are using is completely open source, all the way until basically the hardware design itself. So if you want, you can theoretically go take the design and build it yourself. You also have the open source software with it. And the other is more on the closed source direction, but actually provides you a very robust security certification. And the last part is our unique capabilities with respect to the proof of execution triangulation, or in short, proof of ET, which basically tries to provide you the confidence that actually I'm really talking with a trusted execution environment that is running in a TE and not in our garage. So overall, we of course want to consider other features. So we want to make sure that the host operating system itself is very secure. We want to make sure that we are minimizing the trusted compute base. And we are implementing our own satellite execution assurance protocol, which is the instantiation of this proof of ET concept. And we are offloading the sensitive computation inside of the TE. So you can think of it, it's closer to the process-based execution environments I was talking about in the past, which is something that we still have to fit the context of space because we are power constraints. And in general, the process-based solutions fit better for space itself. But also we want to have the features for the users themselves so that they can actually attest and verify all of these options. From the perspective of how does the workflow actually look like, so we have three main phases, three main stages, where the phase 0 is basically something that is happening prior to each launch itself. So we basically have to take and register some of the unique identifiers for the chip itself. For that, we are actually running our own capabilities with respect to attestation. And this is something that has to happen prior to actually shipping the stuff to space. And here it's important to stress out that only the public information that anyone can theoretically have will be the one that actually will be happening as a part of the setup phase on Earth itself. After we launch the stuff to space, we can start with the phase 1, which is the launch of the components, of course, and basically start the secure boot of building up the root of trust and the trust chain all the way from the software and the hardware together, and make sure that actually the underlying firmware that will be open source and people can go and verify in a reproducible fashion is the correct image that you are expecting. Afterwards, we start with the generation of the on-orbit key genesis, which will be used and interacting with the secure elements on the spacecraft itself to make sure we have actually two different types of key pairs that you can later on use for the signing of the attestation, or possibly also, as you can imagine in the case of space, also have it as a means to prevent single points of failure with respect to the bit flips themselves. Once you are done with the key generation, you will start this satellite execution protocol, which I will just briefly go over, which is basically you can think of it as a simple term as a challenge and response protocol, where you're actually that you know when your satellite will be flying over a specific orbit, and the ground stations on Earth are actually issuing certain type of challenges to the satellite at the respective point in time, and you're expecting a quorum of ground stations to actually send a challenge to your satellite, and you're expecting you will be getting enough threshold of ground station endorsements that actually certify that your satellite is really running in space and you're communicating with the respective environment itself. And after it happens, you meet the threshold. You basically know that your certification can be issued and your satellite is good to go. Important parts, these steps of course, you can do them multiple times, but ideally you only do this once at the setup and you're afterwards good to go. And during the workload attestation, you can theoretically just like always bundle these endorsements and keep using them in the future itself. And this is just the aspect on how does the design itself looks like a bit more in detail. And the cool part will be actually launching this later on this year in October. So stay tuned for more. I don't have time to dive into the details of this aspect, but in general, as I was mentioning, the ground stations are operating, as we know, more from 80s and 90s, which is not ideal. It's more like a dial-up, like that where your mama is telling you, stop playing with the internet, I need to call to someone. And this is basically the state of the ground station themselves, and we are looking for the ways on how to make it reusable with the orbit port itself, which just in general aims to complement and provide this end-to-end confidentiality between the users on Earth and the infrastructure in space as well. I will just skip over this, but in general, what I try to outlined today is our approach to confidential stack, providing confidence to the users on Earth when communicating with space, which is part of the Space Fabric architecture and Orbit port, which is something that we'll be testing actively in the next couple of months and deploying to production with the 3 missions we have in the pipeline. And in case you are interested to discuss more, of course, happy to take your questions. We are looking into integration with different type of hardware providers, security services that you can consume, such as key management services themselves, or if you are a ground station provider, definitely hit us up, and we'll be happy to see how we can use this technology together. So with that, I will thank you for your attention. Feel free to reach out. I will be here until tomorrow, if I'm not mistaken. Yes, it's Sunday. And we'll be definitely happy to brainstorm some ideas and get space built. Thank you very much.